Okay, everyone. Now we're going to take a look at our computer code that is going to be used to control our project and specifically our LED. And I'd like to begin by just reviewing the code and talking a little bit about what the various statements are doing. And then we'll get into actually running the code. And then we'll make some modifications to the code and we will save it. Okay? So we're going to start. As you can see, I have my Raspberry Pi up. It is I'm attached to it via VNC, and so I've got it up on my my laptop screen. I also have a camera set on our project, okay, which we had wired earlier, and it's ready to go. So let's open up the code and talk about that. So we're going to go into the file manager. We'll go into our FreeNov kit, go into code, Python, we'll go to Blink, and we're going to open up blink.py or Python, okay? And this is the new Python editor. And here we have all of our code. And we begin with any line that starts out with a pound sign is typically a comment. However, this very first one is kind of special because it's a directive to the Python compiler, basically saying that we want to run Python 3 on this. We've got both Python 2 as well as Python 3, and we're trying to specify we want this program to run with Python 3. Down below, we've got some additional comments here. Namely the name of this file, a brief description as to what it does, who wrote it, which is the publisher and the manufacturers of our FreeNov kit, and the modification of 2019, December 28. Next, we've got a couple of import commands, and what these commands are doing is they are telling Python that we wish to include a couple of libraries that contain routines that give us additional functionality. Specifically, the first one is rpi.gpio, and we're just going to say import rpi.gpio as just GPIO. We're shortening the name, we're just making it easier for us to code. Next, we're going to import the library time. Now, the GPIO library gives us access to our GPIO pins. It gives us the functionality in Python to literally control and work with the GPIO pins. The library, or the time library, gives us additional functionality with respect to time-related and date-related commands. Okay. Next, we're going to set up a constant here. And we have a name of LED pin. You'll notice that is in camel case. Specifically, we start out with lowercase, and then the next word, if you will, is capitalized. Okay, so LED pin. One of the things you need to remember is that Python and variable names are case sensitive. So if we use a combination of lowercase and uppercase pins, you've got to be consistent throughout your program. So if you will, I'm going to highlight this. Notice by highlighting LED pin, it highlights everywhere else in the program that is used, even in some of the comments. Okay? And what we're doing is we're setting the LED pin to pin number 11. We're identifying the GPIO pin number 11 as the pin that is going to be controlling our LED. Next, we have what is called a function. And a function always starts out with a define, okay? And then the function name with a open and close parenthesis and a colon. So this is the setup function, all right? And then you'll notice that the commands that are in the setup function, they're all indented, okay, by about 4 spaces. And indentation is very important because it helps Python to understand where the instructions belong. And specifically, these group of instructions belong to the setup function, okay? Let's take a look at them. So we start out with GPIO. Now, this GPIO is referring to our library up here where we identified GPIO here, okay? And we then call this method called setMode. And what we're doing is we're telling the GPIO routine or class that what we want to do is we want to use board pin numbers, okay? You can either use GPIO numbers, or you can use board pin numbers, and we're using board pin numbers, and you can see we've already started to specify pin number 11. Okay, well, what's a pin number? Well, in terms of board, we're actually looking at the physical pins. Now, if you recall, on the GPIO, our pin 1 right here, then this is 2, 3, 4. So these are the odds, these are the even pins. So 1, 3, 5, 7, 9, and 11. And that's GPIO 17. So the pin number is 11. And that, you see, our red DuPont wire is plugged into pin number 11, which is also known as GPIO 17. All right, moving on. So we've identified what pin numbers we're using by using this board, GPIO.board. Next, GPIO.setup. Again, another method within the GPIO. And we specify what is the LED pin. Well, the LED pin, as we said, was pin number 11. And we want this pin to be an output pin. And we're using GPIO.out, which identifies pin number 11 as an output rather than an input, okay? Next, GPIO output. So we're specifying that we want to do output on pin number 11, LED pin, and we're setting the output on pin number 11 to low. Specifically, we're setting it to off, okay? So we're going to start with off. And then we print using the appropriate pin number, okay? So it actually is going, when we run the program, it's going to print out what pin we're using. And that pin is LED pin, and which is number 11. Moving on, we have another function. This function is called loop. And as its name implies, this function simply goes around in a loop forever until we hit a control break or a control C on the keyboard. So again, you've got the name of the function, then open and close paren, then a colon. That starts the function. Everything else is then indented. And you'll notice that I've indented 4 right here for the while statement and an additional 4 for everything else. And what this indent, the second indent here, says that all of this code belongs to the while statement. And the while statement belongs to the loop function. This is why, again, why indents are very important. Looking at this, we say while true, which means keep going until some exception is generated. For us, that exception is going to be, there was a keyboard exception, somebody pressed Control C and broke the program. In this loop, every time we go through this loop, we are going to be executing these instructions here. And we start off by, if you recall, we set up our LED for low, which means turn it off. Then we go and we say GPIO output LED pin number 11, GPIO high. So now we're turning the LED on and we're setting the signal on pin number 11 to high. And then we're printing a message out, print LED turned on. Okay, so we literally print that on the screen. And again, these pound signs, whenever you see that pound sign that says that's a comment, computer does not pay attention to those, and those are specifically here to help us understand. Going forward, notice here's our time function, okay, or our time library, and we're making a method call of sleep. And what we're saying is I want you to sleep for 1 second. I want you to wait. Just wait 1 second, okay, before you proceed. So after we turn on the LED, we wait 1 second, which means the LED stays on for 1 second. Then we initiate the next command, Gpio Output, identifying pin number 11 through LED pin. And now we're setting it GPIO low. So we're turning it off, okay? So the LED was on for a second. Now it's going to be off. And we're going to print a message that says the LED is turned off. And again, we're going to say time to sleep, 1 second again. So to go through this entire cycle takes approximately 2 seconds. Okay, primarily because of the two sleep commands, each for a second. Okay. Again, moving on, got another function here. Okay, this function is called destroy. Sounds very ominous, but all it's doing is it's just finalizing. So when we do call destroy, what it does is it shuts down the GPIO pins, and it executes this method called GPIO cleanup. And there are no parameters to it, just open and close paren. And what this does is it just releases all of the resources that have been set aside for us to communicate with the GPIO pins on our Raspberry Pi. Finally, we get to this piece of code down below. Now, I call this the mainline code. Okay, this is the code that runs everything else and calls everything else. And it starts off with a very basic statement. And it asks, is this the mainline? Okay. Name main, all right? That is a standard character for character command. We then, if it is main, which it is, we then print out the program is starting, and then the /n says go to a new line. Then we call, this is a call to a function. So we are calling the function setup, and here's setup up above. So literally we are calling the code setup, and we are going to execute these commands here. Next, we say try. Okay, we want you to try and call the function loop. And at that point, we call loop, and we start executing what's inside loop, which is that loop. And this thing is going to run forever, okay, until we hit accept, and which will be a Control-C, at which point we are then going to run the function called destroy, which is going to shut down our GPIO pins because of the cleanup, and the program is done. Okay, so that's a brief description as to what we're doing in the code. Next, we're going to run our code, and after that, we're going to actually make a modification to the code and see how that works. All right. So having modified, or I'm sorry, reviewed what the code was doing, now what we'd like to do is let's run it. Let's see how this works and is used to control our Raspberry Pi and then our little experiment here with the LED. Okay, so there's my LED over there. I'm going to move this over here a little bit. Bring this in a little bit. Okay. And once I start this running, this is going to disappear, but I'll come over here. And so now what we're going to do is we're going to click on run. We're going to run the program. We're going to see what it does to our LED. So here we go. You can see program is starting using pin number 11, turning on the LED, turning off the LED. It's approximately 2 seconds. Let's take a look at our motherboard here. And there we see the blinking LED. Okay, 1 second on, 1 second off, 1 second on, 1 second off. Okay, so our program is running properly. And what I want to do now is I want to modify this program and get it ready for you to submit for this project. Okay, so we'll put this away, and I'm going to come down here. I'm going to click into the terminal area, and I'm going to hit Control C. And if you recall what that does, that Control C basically says, creates a keyboard exception, and it now runs the function called destroy, which does a cleanup. And this is the result of that destroy, is the program stops running. Okay? Now, next thing I want to do is I want to make a copy of this program. I don't want you to ever modify the original program, so that you can always go back and you can start from the original if you need to. So first thing I want to do is I want to select all of the code in our Blink program. And it's very easy, Control A. So I've selected all of it, okay? And then I'm going to do a Control C for copy. So Control C. Then I'm going to say new. And then I'm going, now that I have a new tab here and blank, I'm going to do a Control V and paste everything that I copied into this tab. Great. Now, a couple of modifications. Okay? We're going to start with student name. And I'm just going to put in my name. Okay? But you would put in yours. And then put in modified and put in a year 21, month 12/01 for the day. Okay? So we see that you modified it. They modified it on 2019. We modified it this year. Okay? So that's the first modification. Now, I want to make a couple of changes to the program here. What I want to do is, if you recall, every time we went around, the very first message that the program started with was program is starting, and then it went to a new line. It then printed out saying using the LED pin, which is number 11. So using pin 11. And then it went around and around in cycle. LED is turned off, on, LED is turned off, LED is turned on, off, back and forth. And that was a 2-second cycle because of these sleep commands here, 2 of them. Now what I want to do is every cycle this goes around, I want to make a count, and I want to display the count on my screen. So I'm going to start by creating a new line, and I'm going to say A is equal to 0. Now you'll notice that this statement is indented like the others down below, all right, so that we know that it belongs to our loop function. Next, I want to go down here, and each time we go around in this loop, I want to add 1 to A. So I'm going to say A is equal to A plus 1. So A is starting off with 0. A, which is 0, plus 1 gives me a new value of A, which is 1. So we're incrementing A by 1. Next, let's print. And we're going to say count is, a couple of arrows here. And then I want to print the value of A. But A is a numeric value. And right now I'm attempting to print a string. So I need to use the string function, which is a built-in function. And we are going to convert A to a string. And I'm going to add another matching close paren. And there is our message. I'm going to put one last thing in here. I just want to put a space in between the prompt here and the actual value of A. Okay, so we have now done that. I want to save this program before I go anywhere else. So I'm going to say save. And I'm going to go into, what I want to do is I want to go into, go back to Freenove, to code, to Python, to Blink, and I'm going to save it under this name. If you recall in the instructions, this is the name I wanted you to give it. So I'm using my name in this this example, Project 101 Blink, then last name, first initial, code, then our version ID 211201, and then Pi for Python. Okay, and we'll say save, and we'll say yes. In my case, it's asking me to replace it because I've already gone through this once. So I'll just do that, and notice it now names that thing right there. Okay. All right. So we've saved it. We've made our modifications. You see what those modifications are. You might want to write them down because you're going to make those same modifications. So stop the recording and just denote where I made those changes. Remember, this, and don't forget our comments up here. Okay, student name and modified. All right. Okay, great. We've done that. Now let's run this thing. Let's see how it flies. Okay, we're going to say run. See that it opens up, and now notice it's going around and it's counting. And if we go over and look at our video, we see that the LED is continuing to light up. All right. Super. So we've made our modifications. The next thing you're going to want to do is you're going to want to get a hold of this code, and you're going to want to submit it to me. And that's part of the instructions that we have. Okay. Okay, let's shut this down. Click on side the window here, say Control C, and the program stops. And we can also click on stop there, and we're good to go. All right. So that's it for the Blink project.